Assalamualaikum and good day everyone. We are from Group 1 from the BITS1213 operating system. Today we will present our mini project entitled Phantom Link Protocol Secure Quarantine Zone Implementation. In this project, we develop an isolated internet network environment and configure several services including DHCP, SFTP, web server and database server. Our group members are including me, Zulifa Humairah for DHCP server, Humairah for SFTP server, Shatish and Agilan for web server, and the last one, Aina Maisara for database server. This project was supervised by Dr. Febrian Rusdi. So without further ado, let's proceed to the network setup and service demonstration.
And good morning, my name is Aina and I will be explain about the network setup for this project. So on the server side, I have configured two adapters, which is adapter 1 is set into NAT for initial package installation, while adapter 2 is our internet network named Phantom In, while we have assigned the static IP of 192.168.1.254. It is for server side. For the client, we have strictly enabled only one adapter, also attached to the same internal network name, which is Phantom In. By disabling all others adapter on the client, we ensure it remains completely isolated from the internet while maintaining a secure connection to our database. Now, let's verify the configuration on our Linux client. To satisfy this project requirement, the client must belong into the same internal subnet as our server. By running IPA command, you can see the interface EMP0S3 has successfully obtained the IP address. This falls exactly within our designated range to confirming that our internal network correctly established. So next, we need to prove that the pipe between the client and the server is functional. I am performing ping to test our database server gateway. So, as you can see, all three packets were transmitted and received with zero packet loss. This confirms that the client has stable high-speed connection to our secure database environment. Finally, we must demonstrate isolation. According to Phantom Link protocol, this client must have no external access. I will attempt to ping the outside world. As you can see, the terminal returns network unreachable. This is the exactly intended behavior. It proves our quarantine zone is perfectly isolated, preventing any sensitive data from leaking to the internet while still allowing us to manage our internal database.
Hi everyone, my name is Zulifa Binti Maisara. So in this video, I will demonstrate the configuration and testing of the DHCP server for the Phantom Link Protocol project. First of all, I will update the package list and install the DHCP server package called ISC DHCP server. Next, I will open the interface configuration file and set interface version 4 to ANP0S8. This is the internet network interface in my environment. This ensures the DHCP only serves the internet network and does not interfere with the internet connection on ANP0S3. Now I open the main DHCP configuration file and delete all default content. I set the subnet to 192.168.1.0, the IP range from 192.168.1.5 to 192.168.1.10, and option routers to 192.168.1.254. The option routers line is critical. Without it, the client cannot communicate with the server. I restart the DHCP service and verify the status. The status shows active and running, which means the DHCP server is successfully configured. Switching to the client virtual machine, I request an IP address using DH client. As we can see, the client successfully received IP address 192.168.1.5, which is within the configured range. I ping the server at 192.168.1.254. The ping is successful, confirming connectivity between the client and server. Finally, I test internet access from the client. The result shows network unreachable. This is the correct and expected output, proving that the client is successfully isolated from the internet. In summary, the DHCP server has been successfully configured and tested. The client automatically receives an IP address and is properly isolated from the internet. Thank you.
Hi, I am Kuchume and I will be demonstrating the SFTP server configuration for the SFTP or SSH file transfer protocol. It's a secure file transfer protocol that's run over SSH on port 22. This unlike FTP, it encrypts both the login credential and the data being transferred. For this project, the SFTP service is configured to listen only on 192.168.1.254, which means it is only accessible from within the internal network. Here, you can see the SSHD config file where I set the listen address to 192.168.1.254 and enable the SFTP subsystem. And here we can confirm that port 22 is only listening on 192.168.1.254 and not the 0.0.0.0. Now I will demonstrate the silent virtual machine. I connect using SFTP researcher at 192.168.1.254 and I enter the password and then we are connected. I run pwd to show the remote directory and then put to upload a file and get to download it back. File transfer is working successfully. That's conclude the SFTP service demonstration. Thank you. I run pwd to show the remote directory.
Hi everyone, my name is Aina Maisara Binti Asri and I will be walking you through the implementation of our database server which secure as the secure vault for our quarantine zone. For this task, I utilize MariaDB to manage sensitive operational data while ensuring strict network isolation. So firstly, I will be showing you security hardening and IP binding. So to meet our critical requirement, the database must invisible to the external network by running SL/TLNP. You can see the MariaDB is listening exclusively on the internal IP on port 3306. I configured this in the file by changing the bind address from the local loopback to our gateway IP, effectively preventing any phantom leaks from the net interface. Inside the server, I created a database named Phantom Leak. Within this database, I designed the sensitive data table to log quarantine file metadata. As you can see, I've populated with sample records like secret blueprint and quarantine log. I also create a restrict user which is internal user with privilege tied to the IP address subnet. This ensures that only authorized client within our quarantine zone only can access this data. Okay, now let's verify from our isolated Linux client. Now I will attempt to connect to the server IP. We are successfully logged into. To prove the integration is complete, I will query the sensitive data table from the server, from the client. So I will run Phantom Leak data and table from the client. So the terminal successfully returns our data, proving that our secure internet pipe is fully isolated and function while remaining isolated from the internet. So in summary, the database server is fully hardened, correctly bound to the internet gateway, as verified as accessibility only by authorized internal clients. This completes the database protocol for the secure quarantine zone. Thank you.
Hi, I'm Satish Agilan. Today I will be presenting about my part, which is web server configuration and client testing. So before we get into the configuration, we need to check our network configuration first. To fulfill our checklist requirement, I will ping Google's public DNS from the server. So this ping is successful, as you can see here. So this ping is successful because our net interface allows outside passage for software uh, package update and installation. So we are ready to install Apache 2. So after I run the bash code, so as you can see, it's the Apache 2 is already been installed in the system. So for the next step, we will be configuring the port binding. So I will open the Apache's primary port configuration file using the nano text editor with admin privilege. Once inside the file, I locate the default wildcard, which is listen 80, and that will be replaced with 192.168.1.254 port 80. So this is very critical security hardening step because it forces the external web server to completely ignore the external internet and strictly process internal traffic coming from our isolated subnet. So after we done with this, we will move on with configuring our virtual host. So we need to modify the virtual host routing rules. So I open the Apache's default site configuration file. So inside this file, I locate the virtual host hashtag port 80. So the default one will be replaced with virtualos 192.168.1.254 port 80. So this ensure our site content is strictly contained within our secure quarantine zone. So after this, we'll need to create a web page. So as I already created, so this is the content for our web page. So after all these steps, we finally restart. Yeah. So this restart is to apply all our network changes. So I restart the web service by running the bash code. So by doing this, we force Apache to reread our modified configuration files. So for now, that's all for our web server configuration. Next, we will move on to client testing. So now that our web server side configuration are verified, I will switch to the client virtual machine to begin our live verification test from a user perspective. So before that, I would like to verify the internal LAN connectivity. So next, I will be verify our internal connection to the web server gateway by running the bash code ping with 192.168.1.254. So as shown by this immediate replies with 0% packet loss. So this conclude our localized network communication layer is fully active and working. So then we will verify the isolation security. So we will ping the 8.8.8.8. So as you can see, this comment is failed. It's shown network is unreachable because this is actually successful proof that our client virtual machine is securely isolated and quarantined from the outside public internet. So after this, at last, we will curl our HTTP, which we just now add the content. So as you shown, it's showing the raw code with the HTML file. So we also can go to the internet service and we can check our website. So this is our website. It's only connected from the internet network. So other than outside network, will be cannot connected. So that's all from the client testing. Thank you. Bye bye.